Hey guys, so in this video we're going over the worksheet that was specifically for F-IF.6. So before we begin, I want to review one key topic that we need in this worksheet. I'm going to zoom in. So when I say the rate of change, this saying also means the slope is interchangeable. So when I mean the rate of change, I mean rise over run. So when we have a graph, we have our y-axis and our x-axis. So we're going to rise on our y-axis, and then we're going to run amount on our x-axis. This translates into a formula when we're giving ordered pairs of y2 minus y1 divided by x2 minus x1. Now, I know some of you have confusion when teachers say, oh, well, you can do it either way. The key is that the 2's match up, they're on top of each other, and the y's are always on top. So you can write this also as y1 minus y2 divided by x1 minus x2. Again, does not matter as long as the 1's match up and the 2's match up. So now, to begin on the actual questions. The graph below shows a distance versus time graph. What is the average speed between 2 p.m. and 4 p.m.? Well, first I want to figure out where my time is 2 p.m. So that's going to be right here. So I'm going to be looking at where my x value is 2 p.m. I also am going to be looking at where my x value is 4 p.m. So I'm going to be looking right here at this line. Then I want to see the distance in between. So at 2 p.m., I have gone 75 miles. Now, I'm going to have some time that passes, and now it's 4 p.m. So right here, and we've gone 200 miles. So in between, our x values have gone from 2 to 4. So 2 hours have passed. And we went, so we're going to have how many miles are in between 75 and 200. When I say in between the number 75 and 200, we're not worrying about whether it's positive or negative. We just want to know literally how much distance is in between. And that is 125 miles. So the question is, which one, whether it be our 2 hours or 125 minutes, which one was our y values on our graph? It was our distance. So we're going to put our 125 miles on top. Then we're going to put our x values. Again, going up to what we did up here. So we've got 2 hours as our x values. When you divide this out, this is hours, you get 62.5 miles per hour. And that will be letter B. Now, going on to the next one. And I know it looks a little bit different from your table, but the hours opened are right here. And the gallons of gas sold are right here. Okay? So it says, the table below, it shows that the number of hours a gas station has open and the number of gallons of gas sold. What is the average rate of change in the amount of gas sold between 3 hours and 8 hours, or hours 8? So I want to come in here and determine what my ordered pair is at hours 3. So I'm going to come in here. It's the second number in the red, and I'm going to get the second number in the blue. So that's going to be my ordered pair for hours 3. So that's going to be ordered pair 3, 1009. Now, for hours 8, I'm going to come down here, and it's going to be 1, 2, 3, fourth number in the red, and I'm going to go over to the fourth number in the blue. And there is our order pair for hours 8. So that will be 3,445. So this is where we want to go back up to the top of our screen and use our formula. Again, either this one or this one, it does not matter. So I'm going to choose one. So I'm going to choose the yellow or the hours 3 first. So I'm going to put the Y first. Then I'm going to subtract. Then I'm going to put the Y value for hours 8. So because I chose the order, this would be our Y1, and this will be our Y2. Because I chose the order I did, I've got to keep the same order for the X values. So the 3 would be X1, and the 8 would be X2. So they've got to match up. So I've got to put the 3 under the 1009, and I've got to subtract the X2, so that would be 8. As I'm simplifying this down, this is what is going to give me the average rate of change in between the 2 hours. So when I simplify this down, I'm going to get 487.2. And that is going to give us C. Remember, you can pause the video anytime if I am going too fast for you. So this is the next one. I believe it's 8. So in this one we're asked, a function is shown in the table below. During which interval was the average rate of change the greatest? So you want to come in here and figure out the rate of change for each. So, and I'm going to try to color code it as much as I can. So we're going to take 0 to 3 and figure out the rate of change. So we've got 1750, subtract 1900 divided by our 0 minus 3. And this is what we're doing for all of them. I'm going to do this one and maybe one other one, and then I'm just going to give you the answers. Remember, we're using that formula that we wrote at the very top of the page. So for this one, you should have gotten 50. So in between here and here, the rate of change is 50. Now the next one would be 3 to 7. So going from the yellow to the blue. So when you're setting this up, you can do it either way. You can do it the second y value first. You can do the first y value first. You just got to keep it consistent throughout the formula. Divided by our x values. So remember, the blue's got to match up. And here, the rate of change in between 3 and 7 should be at 12.5. So I'm just going to go through here, 12.5. Now in between 7 and 9, or the blue and red, the rate of change is 115. And then in between 9 and 11, or the red and the purple, the rate of change would be 30. So if you don't believe me, please take the time to practice finding these rate of changes. But the question asks, which interval has the average rate of, what is the greatest rate of change of these? And the answer is going to be this 115. So that is in between the blue and the red, or the 7 and the 9. So our answer is C. Now, I know that doesn't say 10, but it's question 10. So the table below, it shows the costs to rent a movie for different numbers of days at a movie rental store. What is the meaning of the rate of change for the data? So what we want to do is first find the rate of change, because we're not told that. So we've got to figure out which one we're looking for, the $1.25 or the $2. So we've got 3 days and $6, in between 5 days and $8.50. So I'm going to take the second y value this time. I'm going to subtract the first y value. I'm going to divide by the difference of the x values. So again, taking the second one, because I took the second y value first, and taking the 3. Now this one you should have gotten 1.25. And if you go through each of these, you would get the same thing. So I'll do one more. So the 6 right here. So I'm going to choose the green one first. So I'm going to do the 8.5 again. Subtract. Now the $9.75 divided by the 5, subtract the 6. here you would again get 1.25. So what is this saying? The last one is 1.25 as well. So we obviously can mark out B anyways because it has the cost changing by $2, and that's obviously not the case. But we want to zone in on what this rate of change tells us. Well, under any number, our denominator of 1.25 is going to be 1, always. So if you divide, let's say you had 10. If you divide 10 by 1, you'll still have 10. If it was a billion, if you divide it by 1, it's still a billion. So this 1 that we can put under any number represents our rise over run. And when we're trying to figure out what the meaning of this rate of change means, is that our run is going to be our x values. So as our days are changing by 1, our y value is going to be changing by this top number. So our days are going to be changing by 1. Our total cost is going to be changing by $1.25. So for each additional day, the cost of the rental movie increases by $1.25. So A is our correct answer, and that is all for this one.